So this is the second part of 7.6. We are going to talk about composition of functions. This is when you combine two functions. You form a composite function. Composition, composite. The output from the first function becomes the input for the second function. Okay, so the definition, or to write it out with just the names and variable, we call it g of f of x, or g composed of f of x. So notice that this dot here, it's not a solid multiplication dot, it is open. Like a little itty bitty O, or a little bubble, a little degree symbol, whatever you want to think about it as. Just do not close it in and treat it like a multiplication sign. It might not be a bad idea to write yourself a big note, either next to the definition or next to the heading of it. This is not multiplication. Yes, the dot should be open. It should not look like a multiplication problem. So even though we're using a dot, it's a different type of dot. And even though they have parentheses there, it's not the same idea. This is not multiplication. Okay, so under the definition it says we would evaluate the inner function f of x first. So the inner one, the one trapped inside, is f of x. We evaluate it first and then use that answer inside the g function. So then use your answer as the input of the outer function g of x. Now this sounds a little confusing, but as long as you take your time and you don't try to rush through it, they're not so bad. Okay, on these examples, we've got f of x is equal to x minus 2, and g of x is equal to x squared. So we are first asked to find g composed of f of negative 5. So by the definition, we could rewrite this, if it helps, as g parentheses f of x. Okay. So that means we have to evaluate the f function first. But instead of an x, what am I going to use? A negative 5. See how they put a negative 5 in the back instead of an x? We want to do the same thing. So instead of an x, we're going to plug a negative 5 in. So we start with the inside and then we work our way out. So we are going to start with f and work our way out to g. So if I'm just evaluating f of negative 5, I'm going to rewrite the f function, which is x minus 2, but instead of an x, what am I going to put there?
Negative 5 minus.
A negative 5. So negative 5 minus 2 is negative 7. So the only reason those parentheses are there is because I was leaving a blank for the x. Okay, so if you don't need to write them on that one, that's fine. So f of negative 5 is equal to negative 7. So now, instead of writing f of negative 5, I'm going to now just rewrite this as g of negative 7. That's what I got for f of negative 5. Do we have questions about that first part of it? Now which function am I rewriting? X squared. So the g function. So g of negative 7 is equal to x squared, but instead of writing an x, I'm putting a negative 7. Negative 7 squared is a positive 49. Questions, concerns? Okay, see how we do this one step at a time? It's not so bad. That's it. 49 is our answer. Okay, it's backwards. Letter B is backwards from letter A. Do we think our answer will come out the same?
Yes.
Okay, so it could, probably won't. It's possible though when you compose functions. It's just not very likely. So usually if you're composing functions, doing it one way will result in something different from the other way. Now, that doesn't mean that happens that way all the time, but most of the time it'll be different. So this time, what function is going to be on the outside? F on the outside, and on the inside? G of negative 5. Remember to work inside out. So we start on the inside with the G of negative 5. So the G function was x squared, so I'm going to have negative 5 squared, which is, yes, 25. So G of negative 5 equals a positive 25. Okay, so now I can take that number and plug it in to my composition. So instead of having G of negative 5, I'm now going to have F of what number? 25. Do y'all see how that works? Okay, so now which function am I rewriting? Okay, we're left with F, so we need to rewrite the F function. Yep, so F of 25 is going to be 25 minus 2. Do I really need those parentheses? No, I only use them so that I remember that I'm just putting a blank for the x and plugging something in there. What is 25 minus 2? 23, so that is our answer. All right, on this one, we have that f of x is equal to x cubed, and g of x equals x squared plus 7. Okay? Are these functions printed on your notes already? The ones up at the top? Okay. You just have to fill in what we're doing? Okay. So for letter A, we are going to find g of f of 2. What function is on the outside? Function on the outside. G. What function is on the inside? F, and we're evaluating it at 2. Okay, we work the inside out, so we find f of 2 first. What was the f function? X cubed. So we're going to take 2 cubed. 2 cubed is 8. Okay, so I'm going to take that number, 8, and plug it in for where I had the f of 2 part. So now instead, it'll be written as g of 8. Now we need to go use the g function. G of 8. My g function was the x squared plus 7. But instead of an x, what do I want? I want to use that 8. 8 squared is 64. 64 plus 7 is 71. We all okay with that? So that would be our answer for 5A, 71. On letter B, which function is on the outside? F, and which one's on the inside? G, and what number are we using at first? A 3. So which function am I going to write first? G. We work inside out. So we start with g of 3. So instead of x squared plus 7, I would have 3 squared plus 7. Good. 3 squared is 9. 9 plus 7 is 16. So g of 3 is equal to 16. So now instead of writing this g of 3 here, I'm going to replace it with the 16. So this becomes f of 16. Are you getting used to this pattern? Okay, so now we need to rewrite which function? The f function. So f of 16 is equal to 16 cubed. It's a big number. What do we get when we take 16 cubed? 4,096. Okay, 4,096. We all in agreement on that?
Yep.
And that would be our answer. There's nothing else to do. We already evaluated f of g of 3. Other questions? Concerns? Ready for more of these? It's boring? I'm hoping it's easy. All right. Are these functions printed? G of x equals 2x, h of x equals x squared plus 4. Okay. So I want you to work on at least A through C. Okay. You definitely should have no problems doing A and B. Those are very similar to what we were just doing. What's different about letter C? Okay, you're using the same function twice. So at least start setting it up. If you get stuck, we'll talk about it in a minute. What's different about letter D?
There's a number. Oh, there's not a number. Do you see?
There's not a number, it's a variable instead.
What's the variable?
Okay, so we'll have to talk about how that works. But you should at least be able to get through A and B, because that's very similar to what we were just doing, and we'll talk about them in just a minute. All right, on 6A, what is our outside function? H, and our inside function, g of negative 5. So where are we starting? G of negative 5. G of negative 5 means we are taking what times what?
2 times negative 5.
2 times negative 5. So we just put that negative 5 in for x.
That's negative 2.
2 times negative 5 is negative 10. Do we all get that part? Okay, so now we're going to use that number and replace the g of negative 5 with that negative 10. So this becomes h of negative 10. Are we okay with that? All right, so then we're going to rewrite the h function now. And instead of an x, what are we going to put?
Negative 10.
Negative 10 squared plus 4. What is negative 10 squared? 100. 100 plus 4 is 104. Anybody get that? Few people? Good. Do we have questions about it? Okay, on letter B. Now, what is our outside function? And our inside of what number?
0.
Good. G of h of 0. So we start with which part?
H of 0.
H of 0. So we're going to rewrite the h function and plug in a 0 for x. So we have 0 squared plus 4. What is 0 squared?
0.
0 plus 4 is 4. So 0 plus 4, we get 4. Are we okay with that part? So now that 4 is going to replace the h of 0. 4 replaces the h of 0, so this becomes g of 4. Okay, so we're going to rewrite the g function, but instead of an x we use that 4. 2 times 4 is 8. 2 times 4 is 8. Are we all okay with that? Okay, so the tricky part here is keeping track of which function you're using. So always look to see which function you should be plugging into. Questions, concerns before we do C? Okay, so letter C isn't really any different in the process. It just looks a little funny because our inside and outside function are both h. So we have h of 2. But once we write it this way, our process doesn't change. We're going to use the h function with 2 for the inside part. Okay, so instead of writing an x, I'm going to use a 2. So we have 2 squared plus 4. What is 2 squared? 4 plus 4 is 8. So now instead of the inside h of 2, I'm going to replace that with what number?
8.
The 8. So we end up with h of 8. So we're just reusing the h function again, but this time we're replacing x with what number? The 8. So this time it would be 8 squared plus 4. 8 squared is 64 plus 4 is 68. Questions about letter C? Same process, just looks a little bit different. We'll talk about the C on the next one. We're all okay with A, B, and C though? First 3 problems? Okay, I'm going to make a little space up at the top so that I can work out problem C. It's not C, problem D. So I just don't have enough room down there at the bottom, so I'm just making some room. And I'm going to work problem D up here towards the top. All right, if I wanted to rewrite this, what's my outside function? G, and my inside function? H, and instead of an X, they're telling me to use C. Okay, it's a little different, but it's all right. So let's rewrite the H function using a C. Good, so if we're rewriting the H function using a C, instead of an X, we just put a C. We have C squared plus 4. So this means that I'm, instead of taking G of H of C, I'm taking G of C squared plus 4. So now instead of just replacing with a number, we have an expression. For this last part, I need to rewrite which function? Rewrite the G function and leave a blank for the X. What's going to go inside of that blank? C squared plus 4. Instead of an X, I'm using the expression C squared plus 4. Now what can I do to simplify that? Distribute. We can distribute that too. That'll at least get rid of the parentheses, make it a little bit simpler. Okay, so 2 times C squared. 2C squared. 2 times 4 is 8. So we have 2C squared plus 8 as our answer. Okay, so if they're telling you to use a variable, your answer will have a variable. We could have done the same thing with an X or a Y or a Z, whatever. They're just leaving a variable instead of getting it to a number. So that means if the directions say to use a variable and your answer comes out to be a single number, you probably did something wrong. It also goes the other way. If they tell you to use a certain number and your answer still has another variable in it, something probably went wrong. No more questions on this slide? Okay. So our homework, you should have already done day 1. Should have done day 1 last week. So today we did day 2, so we're going to finish off that assignment. It's on the same pages, but now we're doing 20 through 42 evens. Okay, you should have already done day 1. If you didn't, I would make sure you get caught up on your homework tonight.